Hi everybody. Today we discuss an important concept, lac operon. Lac operon. Lac operon, as the name suggests, that it is something to deal with lactose. Lac for lactose. And operon means, operon, if you want to understand, it is a straight line. Okay, in simple word, it is a straight line. So we can say that it is a linear array. Linear array means a straight line of coordinately controlled gene. So it is a linear array of coordinately controlled gene, or you can also say as coordinate unit of gene expression. If you want to write the definition, you have to write it as linear array of coordinate unit of gene expression. So basically you should first understand what the word means. Lac means lactose, operon means linear array of coordinately controlled unit of gene expression. So this means there would be a something which would be straight in line. There would be certain genes which would be expressed, and if somebody allows them to express, they will all be expressed together. If somebody doesn't allow them to express, nobody would be expressed. Okay, so linear array of coordinate unit of gene expression. And lac operon, lac stands for lactose, and lactose is a disaccharide. It is made up of galactose and glucose. Okay, so galactose and glucose. So these two things, the name is to be clear. What do you mean by lac operon? Now, as we know what is lac operon, and lac operon has been studied in E. coli. Okay, now E. coli requires a fuel to grow as we require, so it requires glucose. So whenever it has glucose, it will not take anything else, it will only take up glucose. Suppose it falls in a glass of milk and it has glucose plus lactose available for its source. If the glass of milk contains lactose and if it has glucose also present, then also, because it prefers glucose, E. coli will take up glucose only. But suppose there is nothing and there is only lactose in the medium. Now E. coli has no this option, as many times we don't have option. So E. coli will also not be having option, and he has to take up the lactose. So this is how we can see lactose operon or lac operon. This means if there is lactose present, only and only if lactose is present in the medium, the bacteria will take up lactose and it will metabolize lactose. This concept, why I am giving this concept is, we'll write it again, that is, if there is glucose present, if there is glucose plus lactose present, and if there is lactose present, that is only lactose. This means our lac operon has to work in this condition when only lactose is present. Okay, but when glucose is present, it will not work. When glucose plus lactose is present, it will not work, because it will always prefer glucose. But when only lactose is present, lac operon will be present. This means indirectly I want to say that lactose induces the lac operon. Okay, so it induces the lac operon. When glucose is present, lac operon is off. When glucose and lactose is present, lac operon is off. When only lactose is present, lac operon is on and on, because it requires the fuel. So lac operon will produce the enzyme which will metabolize lactose, and lac operon has to be on. Okay, so this concept is clear. Now we will see the operon. The operon, which is a linear array of coordinated unit of gene expression. So it is a linear array. So I have drawn a straight line, a coordinated unit of gene expression. So this means there had to be some gene. So there are three structural genes. So coordinated unit of gene expression. Now because there is a structural genes, here we have to say somebody has to regulate it. So there is a regulatory gene. It is represented by I. I always stands for inhibition. Okay. There is a site which is the P site or the promoter site. The P site or the promoter site. And there is a O, operator site. Now this O is very important for us because this O is responsible for the on-off of the lac operon. Okay. So this O is the most important thing, that the operator is most important thing in all this. It is just for your understanding that I am telling that operator region is more important, because something comes and stick to the operator region, and when something comes on the operator region and sits on the operator region, it acts as a big roadblock. You have a speed breaker on the road now, like if there is a speed breaker on the road, the bike will have to bump, or if the speed breaker is too big, or if there is something roadblock, the vehicle cannot move further. If there is a big roadblock, the vehicle cannot move further. Similarly, on the O side, there acts as a big, if something gets attached to the O side, it acts as a big roadblock, and further you cannot move ahead. This means, what I mean to say is that if something comes and attached to the operator side, this thing will not work. Okay, so this thing will not work. Till here we are clear. If something comes and attaches to the operator side, this thing will not work. So I is for inhibition, P is for promoter, O is for operator, which acts as a on and off button. That is a switch which acts as an on and off. If the thing is coming, it is on and it will lead to the production of further structural gene. If something comes and sits on it, there is a big roadblock, we cannot move further. Okay. Now coming to the structural gene. Now what does this structural gene actually do? The Z produces the beta galactosidase gene. Beta galactosidase gene. Y produces the permease gene. And A produces the acetylase gene. Now beta galactosidase means it will break down the lactose into glucose plus galactose. Permease means it allows the lactose, that is the transport of lactose. Transport of lactose. And acetylase also has a function, but I want you to tell me the function of acetylase, especially the PG students should let us know the function of acetylase, because it forms a good question for your Viva. It forms a good question for your Viva, the ones who are taking post-graduation in biochemistry. Otherwise, a UG student whose Viva gets done very well should also know what is the function of acetylase. The function of acetylase is no mystery. You should be knowing the function of acetylase. Let me know the function. If you cannot, I will let you know. Okay? Because for my MD Viva, I was asked a question on what is the function of acetylase, and it actually is a good question. Okay? So inhibition, promoter, operator, beta galactosidase, permease and acetylase. Now the thing is that I just want you to clear one thing, that it is a polycistronic mRNA that is produced. Now what do you mean by polycistronic mRNA? Polycistronic mRNA means polycistronic mRNA. This means it has a start codon, a stop codon, a start codon, a stop codon, a start codon and a stop codon. It will produce 3 different genes, and it has a different translational machinery for every gene. Okay, so it is a polycistronic mRNA. Are we clear with the lac operon structure? It has a regulatory gene I, a promoter gene, a operator gene, a Z structural gene for producing beta galactosidase, which will break the lactose into glucose plus galactose, permease which will transport lactose, and acetylase which has an important function that you people will let me know. So polycistronic mRNA, that is the different translational unit. Are we clear with this? Now we get on to the mechanism of lac operon. So the lac operon, as I told, has a regulatory gene, promoter gene and operator gene. I is for inhibition, that is the regulatory gene. Normally what does it do? I forms repressor subunits. I forms repressor subunits. Okay. So I is forming repressor subunits and it is called as lac repressor. It is called as lac repressor. Generally I will produce lac repressor subunits. Why? Because I is constitutive gene. Constitutive gene is also called as housekeeping gene. What do you mean by housekeeping gene? The one housekeeping means the one who helps to keep our house clean. It's called as a housekeeper. So housekeeper or a housekeeping or a constitutive gene. As we require a housekeeper every day, it is an important part of our life. So everybody has to keep their house. Now you have to keep your house clean. Similarly, housekeeping means every day this gene is there. This means every time the gene is produced. So constitutive or housekeeping means it will be produced. Okay, it has to be produced. It will be there in the medium. So I will always produce lac suppressor unit, and this lac suppressor subunit, what will they do? They will go and join this operator unit, and now they form a big roadblock. Okay, now they form a big roadblock and things cannot go further. Okay, things cannot go further. So when lac suppressor subunits bind to operator, the things do not go further, and therefore it is called as repressor molecule. The repressor molecule acts as a negative regulator. The repressor molecule acts as a negative regulator. Okay, so the repressor molecule acts as a negative regulator of gene expression. So this is repression of lac operon by lac repressor subunit. So lac repressor subunit binds to the operator gene, further nothing can take place. So repressor molecule acts as a negative regulator. Now this happens when we have glucose in the medium and lactose is not to be metabolized. See, everybody, like you people, save money. E. coli also saves something for themselves. So E. coli is saving the energy. Why to waste energy in synthesizing enzyme when glucose is there? Why to waste energy in synthesizing enzyme for lactose? Okay. Now what happens if suppose lactose is present in the medium? Okay. So I will always produce lac suppressor subunits, but now I have lactose in the medium. So this is the lactose which is there in the medium. So this lactose, I have lactose. Only I have lactose. So repressor subunits will combine with lactose. And what will happen? Their conformation changes. See, their conformation is changed and they no longer can bind here to the operator. So they no longer can bind here. When repressor subunits combine with lactose, the conformation, this word is very important, that the conformation changes and they no longer can bind on the operator side. So the O region is empty, the O is on, the switch is on. Now what happens is, on the switch is on, now the machinery can work ahead. But as we know, we require an enzyme for further process to take place, and the enzyme is RNA polymerase. So this RNA polymerase will bind to the P site, that is the promoter site. So RNA polymerase binds to the promoter site so that the structural genes can be produced and the further process can take place. Okay, RNA polymerase will bind, it will allow the formation of a polycistronic mRNA, which will allow the formation of the 3 enzymes. Fine, but there is a catch in this. Now RNA polymerase cannot themselves do everything. They require a help, and this help is given by catabolite activator protein and cyclic AMP. Catabolite activator protein and cyclic AMP. Okay. So now what happens when these two attach to the promoter site, RNA polymerase can also attach, and finally the operator allows the switch to be on and transcription, polycistronic mRNA and translation takes place. So now we can say that lactose is inducing the operon and catabolite activator protein or catabolite gene activator protein cyclic AMP is a positive regulator for the lac operon. Okay, now we call this as de-repression of lac operon. So we had a repression, we had a de-repression, inducible, positive regulator and negative regulator. Everybody is clear with this? Now the question that can arise is, what does glucose do so that it makes glucose the preferring thing? We had discussed whenever there is glucose present, it will take up glucose and lac operon will not take place. This means glucose has to do something so that something in the lac operon doesn't take place. So what will it do? We had seen that cyclic AMP is an important thing. Okay, cyclic AMP is an important thing in the mechanism of de-repression that allows the RNA polymerase to bind and further the process take place. Adenyl cyclase. Okay, so ATP forms cyclic AMP. But what does glucose do? This cyclic AMP is required. It binds with catabolite activator protein cyclic AMP to the promoter site, and then this RNA polymerase will bind, and so it is important for us. But what glucose does? It inhibits the adenyl cyclase. So cyclic AMP is not formed, or it is not formed, and further catabolite activator protein cyclic AMP cannot form, and the process of lac operon doesn't take place. So this is the basic how glucose helps, or rather it tries to stop the lac operon when glucose is present in the medium. Glucose inhibits adenyl cyclase. It will not form cyclic AMP, and therefore lac operon will not take place. Now this is clear. This lac operon is the short note for UG and PG, and it acts as it comes as an MCQ on various things like what is the promoter site, what is the operator site, or what is gaseous inducer. So gaseous inducer is isopropyl thiogalactoside. Okay, so this is actually an analog of lactose. This is an analog of lactose, but the catch is that galactosidase enzyme will not act on it. The galactosidase enzyme will not act on it. It is not the substrate for it. Okay, it is just for research purpose, and this is also asked as viva. So isopropyl thiogalactoside is an analog of lactose where galactosidase will not act. It is only for research purpose. Lac operon should be very clear. The concept should be very clear, and there are other operons also. It is, if somebody asks you, so there is a tryptophan operon, arabinose operon. Arabinose is a sugar, or tryptophan is an amino acid. There is heme operon. Okay, so these are the other examples of operon. Lac operon is, to summarize, lac operon is active only if lactose is present. Okay, it was found by Jacob and Monod. So we are very thankful to Jacob and Monod that they helped us in understanding a part of gene regulation. That's all for today. Thank you.